Before we get to tearing down polynomials from expanded form into factored form, it's probably helpful to spend a little time learning how they are built up so you can understand better how to take them apart down the road. So, as we mentioned, when you're dealing with complex zeros, they come in conjugate pairs. And we probably would want to review very briefly, well, what do you mean by a conjugate? Let's talk about that briefly. So a pattern that's very useful when you're dealing with this, a factoring pattern from algebra, is what we call the difference of squares pattern. And that pattern says that when you have something of the form a squared minus b squared, that always factors in a predictable way. It's a plus b times a minus b, or vice versa, right? The order of the factors doesn't actually matter because a plus b times a minus b is the same as a minus b times a plus b. Multiplication is commutative, right? Anyway, if somebody were to ask me, like, hey, what's a conjugate of a complex number? One way to explain it is to say that it's effectively, it's like visualize the other half of the difference of squares pattern, and that will tell you what the conjugate of a number is. In other words, think of it like this. Let's say we have a number and we have a conjugate. So maybe we would start with a complex number like 3 minus 2i, and we asked you, hey, what's the conjugate? Well, if 3 minus 2i is part of a difference of squares pattern, then the other term is going to have to be 3 plus 2i, and that's the conjugate. If you had something different, like minus 4 plus 5i, and we asked you, hey, what's the conjugate? It's the sign in the middle that changes. So the conjugate would be minus 4 minus 5i. You notice the minus 4 stays minus 4, right? Because we're only changing the sign in the middle in order to transition from the number to the conjugate. So in general, if you have a complex number of the form a minus bi, the conjugate is a plus bi. And in a similar fashion, if you have a complex number of the form a plus bi, the conjugate is a minus bi. And so you have to understand conjugates if you're going to talk about polynomials that have complex roots. Now, we had mentioned previously this idea that when you have complex roots and you have real coefficients, we know that the complex roots are always going to come in even numbers. So there's going to be 2 or 4 or 6 or whatever, however many the polynomial has. And that's because they're conjugate pairs, right? So when they give you a question like this next one here, they're basically asking you to use the provided information to construct a polynomial which could have the required features. They want a polynomial q of x. They want it to be third degree, and they want it to have a 0 at -3 and another 0 at 1 plus I. So the first item you have to recognize is that they haven't given you 3 zeros directly, but they have given you 3 zeros indirectly. And so we know that if you have 1 plus I as a root, you're also going to have 1 minus I also. And so we're going to start off with this as follows. We'll say, well, we have q of x, and it's going to be equal to quantity x plus 3. That's coming from the 0 at -3. As for the 0 at 1 plus I, that's going to be x minus the quantity 1 plus I. And as for the 0 at 1 minus I, that's going to be x minus the quantity 1 minus I. You have to remember that when we were talking before, let me switch to the slides here real briefly. We had mentioned that when you go back and forth between the factored form and the expanded form, that we always represent the quantities involving the roots as x minus r sub 1, x minus r sub 2, and so on and so on and so on. And so that's what we're doing here. That's why there's a minus sign in between the value of x, or between x and the root. So now you need to do some expanding. And if you simplify this a little bit, everybody has their own preference when it comes to expanding. Let me show you what I prefer to do. I prefer to keep the complex numbers with the complex numbers. I find it just smoother that way. So in other words, I'm going to start expanding, and I probably need a longer line for that. So let me tee that up. I'm going to have x plus 3. And when you multiply x times x, you get x squared. When you multiply x times the quantity minus 1 minus I, so in other words, I'm considering that sign right there as part of the quantity, you're going to have minus x times the quantity 1 minus I. And then when you take minus quantity 1 plus I times x, you get minus x times 1 plus I. And then you have minus times minus, so that's positive, and you're going to have positive 1 plus I times 1 minus I. And so we need to do a little bit of additional expansion before we can clean that up. So we have x plus 3. And when we expand that minus x times 1 minus I, you're going to get minus x. And then minus x times minus I is plus x times I. And likewise, minus x times 1 is minus x. And then minus x times minus I is minus x times I. Now, the 1 plus I times 1 minus I, that conforms to the difference of squares pattern that we were just talking about up here, right? So when you expand that, that's 1 squared minus I squared. And so you can just cut to the chase on that. It's going to be 1 minus I squared. Now, I squared is negative 1 by definition, right? And so that quantity right at the tail end of that there, the 1 minus I squared, is really the same as 1 minus a negative 1, or 1 plus 1, which is 2. So here's what we have. We have x plus 3. And then as we clean this, we notice that there's stuff dropping out. The x times I terms are opposites. They drop out. And then I have minus x and minus x. So I have x squared minus 2x. And then I have 1 minus a negative 1. So that's negative 1 right there. That's 2, like we said. And so I'm almost home. I need to keep on expanding a little bit more. So x times x squared is going to give me x to the third power. X times negative 2x is minus 2x squared. X times 2 is 2x. 3 times x squared is 3x squared. 3 times negative 2x is negative 6x. 3 times 2 is 6. And so now I can clean my like terms up, and I'm home free. I'm going to have q of x. It's x cubed. I have a negative 2x squared and a positive 3x squared. That's going to give me x squared. And then I have, let's see, a 2x and a negative 6x. That's minus 4x. And then I have 6. And at that point, I'm done. So if you're feeling confident, you could pause the video and you could work out this very next example, because that's what we're going to do. We're going to look at one more final example in this vein before we move along. This is a little bit more demanding. You can see that there's more information. It has a higher degree and so on. So if you're feeling confident, you could stop the video here and work it out on your own and see if you match. Let's take a shot at it. So they're giving us a fifth degree polynomial. They're telling us that we have 2 real zeros, and one of those real zeros has a multiplicity of 2. They're also telling us they want a leading coefficient of 4, and they're giving us a single complex root. So as far as the root at 0, well, let's put it this way. People get confused by minus I, but you need to think of it the right way. It's actually 0 minus I. And so the conjugate, it's 0 plus I. And so in other words, this is going to have minus I and I as roots. And so with that, we can pretty much get going here. So u of x leading coefficient of 4. We're going to have x minus a half. And they say that we want the root at -1 to have a multiplicity of 2. So that would be x plus 1 quantity squared. And then we're going to have those complex roots. And so if you want to write it, you know, in the same style that we did on the previous problem, it's really not necessary, but whatever, it's fine. We're going to have x minus the quantity 0 minus I, and then x minus the quantity 0 plus I. Now, of course, once you start to simplify that, you can see that you don't really need to write it in that fashion. But anyway, here's the deal. A couple of things going on. First of all, I'm going to distribute that 4 over the quantity x minus a half. I don't like having a fraction in there if I can avoid it. So that's going to give me 4x minus 2. And when I square out that x plus 1, I'm going to have x squared plus 2x plus 1. And then as far as the complex, I'm going to have x plus I. It's minus a minus I, and then minus I, so x minus I. And in terms of expanding, I think what I want to do is I want to go with those two together right there, and I want to go with those two together right there. That makes the most sense to me. So when I multiply 4x minus 2 times the quantity x squared plus 2x plus 1, I get the following. I'm going to have 4x times x squared, which is 4x cubed. 4x times 2x, which is 8x squared. And 4x times 1, which is 4x. And then negative 2 times x squared is minus 2x squared. Negative 2 times 2x is minus 4x. And negative 2 times 1 is negative 2. Now, x plus I times x minus I is difference of squares. If you want to show the details, it's going to be x, or well, let's be real clear here. So you're going to have x squared minus I squared. Do you agree? And so when you continue to simplify that, remembering that I squared is -1, here's what happens. We can do a little bit of cleanup on both of those there. So in that first quantity, the only cubic term is the 4x cubed. But I have a couple of square terms. I have an 8 and a -2, so that's going to give me 6x squared. And then I have a 4x and a -4x. That goes away. And then I have a -2. And then x squared. And minus a -1, of course, would be plus 1. So I'm almost done. Or well, there's going to be a little cleanup, and then I'll be done. So I'm going to keep on expanding. 4x cubed times x squared would be 4x to the 5th. 4x cubed times 1 would be 4x cubed. 6x squared times x squared would be 6x to the 4th. 6x squared times 1 is 6x squared. -2 times x squared is -2x squared. And -2 times 1 is -2. And so as far as the final answer is concerned, there's a little cleanup there, not that much. But anyway, let's write it properly and so on. So I'm going to have 4x to the 5th. I'll have 6x to the 4th. I'll have 4x cubed. And then 6x squared and -2x squared is going to be 4x squared minus 2. And at that point, there really ain't much else to do. I'm done with that. And I'm sure that that's how the learning management system would want that answer to be entered. Surprisingly, this is one of those kind of problems where a lot of people will make mistakes. The complex arithmetic is something that a lot of folks are kind of iffy on. And so that would be one of those kind of things where, you know, I would say, well, you know, I don't have time in this series to reteach complex arithmetic. You kind of have to get that, you know, from YouTube or from your text or something like that. Anyway, stay tuned for the next video.